A data structure has two components. It has an interface and an implementation. The interface, also known as an abstract data type, is basically saying, these are the things that my data structure does. And my implementation is saying, this is how my data structure does these things. This is a pretty abstract notion, so more concretely, we use the example of the interface being either a stack or a sequence or a set. For example, the sequence interface says, okay, I don't really care how you store your data, but I need to be able to have a function that says, like, get me the third element in this data store. So there has to be some notion of, this is the first element, this is the second element, this is the third element. I have to be able to call for the length of the sequence, and you have to be able to return it to me, and so on. So this is like the list of instructions. And there are ways you can implement it. Like, we have the set of rules we have to obey, but we can store our data in any way we want. We could use a linked list, or we could use a static array, or we could use a dynamic array. And there's trade-offs between using different implementations. Some things might be quick with one implementation, but it might be slow with another one. Maybe if you use an array, you can get really quickly, but you won't be able to, delete quickly. A couple implementations of a sequence or a stack are linked lists, which hopefully you guys are familiar with, and static arrays, which hopefully you guys are familiar with as well. We introduced dynamic arrays, and these are better than static arrays because for static arrays, let's say we had the sequence and we wanted to add the number 4. Well, we'd have to reallocate the memory into a new array. Like, basically delete this array and make a new array, because arrays have a fixed length, at least static arrays do. So dynamic arrays try to go around this problem by saying, okay, instead of using just one fixed array, we'll say, this is now our array. Now when I say insert something at the end, we have some extra space at the end of the array to add like another element and another element. And then if we want to delete, we just get rid of this element, and so on. So now, most of the time, when we call insert on a dynamic array, it's just going to take one operation. Our array is already big enough, so we can just insert. The only time this is bad is when, let's say I call insert, then I call insert again, then I call insert again, and then I call insert again. Now our array's full, so we have to reallocate a new array. And we allocate a new array of length like 9, so we can add the final thing. What a dynamic array actually does is that it doesn't allocate the new array of length 9, it doubles this in size. So now we have an array of length 16. So we add 9 and then we have extra space again. So if we were analyzing the runtime analysis for this function, insert, it would be something like, okay, I called it this time, it took 1 step. I called it this time, it took 1 step. And almost always it's going to take 1 step. Except like on the rare occasion, it takes n steps. Or in fact like 2n, because it allocates an array of size 2n. So we can say, oh, okay, insert's not that good. Worst case, it'll take O of n steps. This is where amortized analysis comes in. What do we realize? Like, we have an array of length n. If we call insert n times, we're guaranteed that this bad case only happens once. There's no way we're going to have more than one array doubling within n times, because every time we double, we allocate n extra space. So we're saying, okay, just because this is worst case O of n, if we called this, some number of times, the total runtime is like n times 1 plus 1 times n, which is like 2n, which means the average runtime per call is 2 steps, which is O of 1. And that's why we say, okay, worst case, it's O of n, but amortized worst case, it's O of 1. So amortized analysis is some notion of average, but it's not the same as average case. This is not averaging out of all possible inputs, but it's averaging out of, if I call this a bunch of times, what's the average runtime per actual call of the function? So that's a pretty subtle distinction. We talked about this issue of memory overhead. Like, if we kept doubling and then kept deleting everything, maybe we'd have an array that actually just has length 1, but because we kept doubling, the array itself is really, really big. So there's this notion of array halving. Once an array is only 25% full, we halve it, so that there's less memory overhead. There's less extra space that we're taking up but not actually using. Finally, we talked about the set interface. And a big source of confusion is that if you guys have used what's called a set in Python, this is very different than the set interface. The set interface is key value pairs. So in your head, you should be thinking something like a Python dictionary as opposed to a Python set. And there's a bunch of little details that we went over in lecture, but essentially a set interface is another interface where you have this list of instructions that you have to do, and there's different ways of implementing it. Some have their pros and cons, are fast on some instructions, slow on other instructions. And we'll see in recitation, it's really important, but also pretty tricky to find the right implementation for a certain interface. Oftentimes, you'll be given a list of instructions and be required to say, okay, I must be able to get in constant time. I must be able to set in constant time. And maybe I'm allowed to take O of n time to return all the things in order. But you have to be able to, given those requirements, think of an implementation that matches those requirements. Some of this is, I know it's a bit abstract, and a lot of it's sort of like scaffolding so that we can get into the more interesting stuff later on. But try to slowly get better at understanding these abstract data types and distinguishing between them, because these are all really, really important concepts. Absolutely feel free to ask if you have specific questions about specific details in lecture.